we need to first see if there's any common factor, any multiple that I can get out. Just looking at it, I believe that if I divide each one by 2, then I can simplify or reduce, and that would be x squared plus 3x plus 2. Now let's double check our work. 2 times x squared is 2x squared. 2 times 3x is 6x. And 2 times 2 is 4. So I believe we've got our greatest common factor out. Now we are looking for we're going to put the 2 here, and we're going to put the 3 here. This is the last one and the middle one. And then we're going to find what multiplies to 2 and adds to 3. Well, that's 1 and 2. 1 times 2 is 2, and 1 plus 2 is 3. So our factors are x plus 1 and x plus 2. Those are our factors. There is a common factor of 5. So if I divide each piece by 5, I can see if it works. So that 5 is out here in front. It doesn't disappear. So 5 divided by 5, okay, that's x squared. 25 divided by 5, that's 5x. And 30 divided by 5, that's 6. So now we have our trinomial. In our trinomial, we put our 6 right here and our 5 right here. We need to find something that multiplies to 6 but adds to 5. That would be 2 and 3. 2 times 3 is 6, and 2 plus 3 is 5. So our factors are x plus 2 and x plus 3. Find your greatest multiple, your greatest common factor that you can pull out. I believe it's going to be 3. So if I divide each term by 3, I now have x squared plus 7x plus 10. And of course the 3 doesn't disappear, it's still sitting there, isn't it? Right now I'm looking for something that multiplies to 10 but adds to 7. Multiplies to 10 and adds to 7. I believe that's going to be 2 and 5. 2 times 5 is 10. 2 plus 5 is 7. So now we have 3, because that doesn't go away. We have x plus 2 from here. And we have x plus 5 from there. And that's our answer. Let's find our common factor. I believe our common factor is going to be 9. So if we divide both of these by 9, and remember the 9 doesn't disappear, it's just sitting here. 9 divided by 9, okay, that's x squared. And 36 divided by 9, that's 4. Now there are only 2 terms, so we are looking for a pattern. We are looking for a pattern. What about a pattern of squares? Is this an x times x? And this is a 2 times 2. Then our factoring is x plus 2 and x minus 2. The reason the middle term is missing is because one is plus and one is minus, and that's the reason the middle term is missing. Greatest common factor, we always look for that first. So I believe if we divide both of these by 2, we will get 9x squared minus 4. Now since there's two terms, we are looking probably for a pattern. If we're looking for a pattern, what about squares? Is this 3x squared? That's 3x times 3x and 2 times 2. Those are squares. So that means that our factors are 3x plus 2 and 3x minus 2. The reason there's no middle term is there is a negative and a positive, and that's why. And we don't forget our 2, which is sitting out here that we divided by. The first thing we look for is always greatest common factor. So the greatest common factor is 3, I believe. So if we divide this by 3, we get 12 divided by 3 is 4y squared. 75 divided by 3 is 25. There are two terms. If there are two terms, then we're probably looking for a pattern. The pattern might be squares. So would you agree this is 2y times 2y? Is this 5 times 5? If that's true, then our factors are 2y minus 5 and 2y plus 5, because the negative and the positive are what make the middle term disappear. And of course we need to make sure we put in our factor that we took out at the very beginning of 3. Alright, well, the first thing we're going to do is look for a GCF. Unfortunately in this one we can't find a GCF. It's not a 3, it's not a 2, so we're unlucky enough to get one that we have a leading coefficient greater than 1. When we have a leading coefficient of greater than 1, we have to look for longer patterns. So now this is 3 times 36, which is 108, and we put 31 right here. So we need numbers that multiply to 108 but add to 31. Now this can be a little daunting, so you can start dividing by 2 or 3 or 4. Why don't we start with 3, because we know we're going to have to go for a while. 3 and 36. Well, that doesn't give me any pattern that I can see. 27 and 4 and 18 and 6. Okay, well, 27 and 4, there's the pattern that I'm looking for. Now you can use any way you want, but I tend to use this graphic organizer to help me out. If I put these two factors in one of those boxes, I will be able to start finding the pattern for this. Which one is most like 3? Is it 27 or 4? Because it doesn't matter which box I put it in, it'll still work. But I think I'm going to put 27x in this one, because that gives me a greatest common factor. That gives me a greatest common factor of 3. Well, something times 3x is 3x squared. Something times 3x is 27x. That has to be a 9. Something times x is 4x, so that must be 4. If I did it right, 9 times 4 is 36. So my factors are x plus 9, 3x plus 4, and we don't have a greatest common factor this time. Do we have a greatest common factor? No, we don't. So we have a leading coefficient greater than 1. Makes things a little more complicated, but we can do this. Alright, so the first thing I'm going to do is multiply 5 times 26. That's 130. And I'm going to put my 23 right here. So I have to come up with things that multiply to 130 but add to 23. They multiply to 130 but they add to 23. Well, 2 comes to mind. That's, let's see, what is 2? 2 is 65. There's no 3. There's a 5. That's a 26. Still don't see anything. Oh, the next one is 10 and 13. Yeah, that's it. 10 times 13 is 130, and 10 plus 13 is 23. I'm going to use my graphic organizer to help me out. I have to get the right numbers in there. 5x squared. I know this has to be 26. And I can put 10 and 13 anywhere I want. I'd kind of like to put 10x right there because that gives me a greatest common factor right off. 2. Alright, then 10x down here is 13x. So x times something is 13x. That's 13. And if I did it right, 2 times 13 is 26. So x plus 2 and 5x plus 13.